this is the second class on problem solving on SAT. The third problem, the last video I have explained two problems, that is very lengthy. So now come to the third problem. You have to solve square root of whole power of minus 4 into minus 2. So how will you solve that? As because you can see the bases are same, as the indices also only different. So I can, as per the rule, I can bring it together and I can calculate. As because this is multiplication, the indices will be added up. So this will become something like that. You know, a to the power m into a to the power n will give you a to the power m plus n, where m and n would be any integer, positive or negative, and whatever the sign it will bear, the same will carry over here also. So that's why the signs also carries, and only the summation is happening. So root 3 whole to the power minus 6. Now 3 to the 3 square root means 3 whole power 2, half 1 by 2 whole power 6. Now here another thing comes into picture. M whole to the power n, it will be nothing but the multiplication of this number. Means when I will remove the bracket, these two together will be multiplied. So here also the same thing, half into minus 6, where minus 6, if I calculate, I will get something minus 3, because 2 will be cancelled out, minus will be there. So now again a to the power minus m, I can write 1 to the power a to the power m. So in this the same, if I follow 3 to the power 3, now 3 to the power 3 is nothing but 1 to the 1 by 27. So this is your answer. Come to the next problem. The fourth one. Is find the rationalizing factor. That I have already explained, still I am showing you rationalizing factor for this one. So you know, the after rationalizing I will get 5 as the rational number. So I divide 5 upon cube root of 5. So this give you 5 whole to the power, cube root means 1 upon 3. 5, the indices will 1 upon 3. So this will, when will go up, it will be calculated as this. Okay, because a to the power m by a to the power n is nothing but a to the power m minus n. So whatever be the value, whether it is integer or fraction or decimal, it will become as the same form, but when it is in form of division, only the negative sign will come in the indices. That the only change will come. But you remember, this basis should be of same manner, of same or has to be same. It should not be a different one, otherwise it will not work like that. So 5 to the power 2 by 3 will be the rationalizing factor for this. Okay, so this is your fourth problem. Come to the next sum, 5. It says simplify 5 minus root 20 plus 7 root 5. You have to simplify this. So to simplify this, this is somewhat in the form of SAT, which is simple in a manner. It is not a pure SAT, because if this brought to a simplest form, where anything like that, let's say 2 root 5, if I want to bring in the simple form, it will be like that. It will go inside, so in the form of square of that into 4, so it will give you a simple SAT, that is equal to, but this is not a pure SAT, because if I simplify this, it will be a rational number outside, so it is not a simple surd. Okay. Or other terms, you can say it a radical sound. Is also in other terms it's called a radical surd. Okay. So this is the term by which you can call, but it is not a pure surd. You can remove. So what you have to do, you have to simplify this. How to simplify? You have to try to bring the maximum factor of 45. So if I bring it 3 into 3 into 5, I can say. Here I can do similar way, 2 into 2 into 5 I can say. Here you cannot bring it as root 5 is the irrational number, so you cannot bring anything out of the root. So here, as because it is 2, 3 are there, as it is a square root, so I can bring out 1, 3 out, and the remaining irrational number I will leave it as it is. Other way, this also will bring 2 outside root 5 here, then the remaining will be as it is. Now if I calculate, it is 9 root 5 minus 2 root 5 plus 7 root 5. Now taking the plus sign together and minus sign separate, I can get it 16 root 5 minus 2 root 5, which will give you 14 root 5. This is your answer after simplification. Okay. So this is your fifth problem. Come to the problem sixth. Again is simplification, but it is in a different manner it has been given. So it is written as 245 plus 51 plus, it's somewhat like marathonic kind of simplification, because you have to come one after one. You cannot do all the operation together. Here you have to try to remove the innermost surd to simplify, to bring it as a rational number. You have to try it like that if it is possible. So your possibility in this case only, you have to bring this surd to a rational number, then after you have to come to this surd, then have to the final one. So this is a something like the inside to inside solving. So I cannot do all the operation together, so I will have to write all the things as it is. Only you have to focus on the first surd. So if you know 169 is nothing but 13 square. Okay, so if I write it 13 square, next step I can solve it to write as it is 13 square, it's a square root, so only 13 will come out. Okay, so then next step, as because those are of same rational number, then I can add or subtract whatever the function it is applicable here. I will do it keeping under the surd. So 51 plus 13 gives you 64. Now I have to try for this surd to bring it outside the surd. So what is that? 8 square. So now it is 245. 8 will come out and that surd will abolish. And now come to the next last step, which is equal to 48 plus 8, 256. Now 256 is nothing but 16 square, I suppose. 16 into 16, 96. 16 plus 9, 20, yes, it is 16 square. So when it will come out of the surd, so this is the simplest form of this. So in this case, you remember, you have to start from this side, one by one you have to remove all the surds. Okay, so this I call the end of this session, and next I will bring more problem for you, a different problem, so that you can understand all aspects of the surd, how to solve the problem. Thank you.